NEC Section 820.96 addresses the bonding and grounding of community antenna television or CATV systems. Specifically, subsection B focuses on CATV grounding. Where an electrode is provided for grounding the coaxial cable, the grounding conductor must be as short as practicable. There is also a length constraint. The code states that in no case shall the grounding conductor be longer than 20 feet, which is equivalent to 6.1 meters. Furthermore, the grounding conductor must be shorter than the length of the grounding electrode itself. The grounding electrode system installation is critical for providing a low impedance path for fault currents, protecting equipment and personnel from electrical shock. The importance of minimizing the length of the grounding conductor is for several reasons, primarily related to impedance. A longer conductor introduces higher impedance, which can impede the flow of fault current to ground. Firstly, impedance is the total opposition to the flow of alternating current in a circuit. It's a combination of resistance and reactance. Secondly, reactance is the opposition to current flow due to capacitance and inductance. In grounding conductors, inductive reactance is the more significant concern. Thirdly, inductance increases with the length of the conductor. A longer grounding conductor has higher inductance, resulting in a higher impedance. This higher impedance can reduce the effectiveness of the grounding system by limiting the amount of fault current that flows to ground. A high impedance grounding path can delay the activation of overcurrent protective devices, such as circuit breakers or fuses, during a fault condition. This delay can increase the duration of the fault, leading to greater damage to equipment and a higher risk of electrical shock. By keeping the grounding conductor as short as practicable, the impedance is minimized, ensuring that fault currents can quickly and effectively flow to ground. The 20-foot maximum length requirement provides a clear, enforceable limit on the grounding conductor length. This limit helps to ensure that grounding systems are installed in a manner that minimizes impedance and maximizes their effectiveness. It is important to note that the phrase as short as practicable implies that the grounding conductor should be even shorter than 20 feet whenever possible. In many installations, it is possible to achieve grounding conductor length significantly less than 20 feet. The requirement that the grounding conductor be shorter than the grounding electrode length is another important aspect of NEC Section 820.96. This requirement ensures that the grounding electrode is the primary path for fault current to ground. If the grounding conductor were longer than the grounding electrode, the grounding conductor itself could become a significant source of impedance, potentially reducing the effectiveness of the grounding system. The purpose of a grounding electrode is to provide a low impedance connection to the earth. Common grounding electrodes include ground rods, ground plates, and metal water pipes. The effectiveness of a grounding electrode depends on several factors, including the type of electrode, the soil resistivity, and the depth of the electrode. To ensure that the grounding electrode is effective, it is important to select the appropriate type of electrode for the specific soil conditions and to install the electrode in accordance with NEC requirements. Soil resistivity is a measure of the soil's resistance to the flow of electrical current. Soils with high resistivity are poor conductors of electricity, while soils with low resistivity are good conductors of electricity. In areas with high soil resistivity, it may be necessary to install multiple grounding electrodes to achieve the required grounding resistance. The NEC provides specific requirements for the installation of grounding electrodes. For example, ground rods must be at least 8 feet long and must be driven into the ground until at least 8 feet of the rod is in contact with the soil. Ground plates must have a surface area of at least 2 square feet and must be buried at least 30 inches below the surface of the earth. Metal water pipes that are used as grounding electrodes must be in direct contact with the earth for at least 10 feet. In addition to the requirements for grounding electrodes, the NEC also provides requirements for the bonding of metallic components of CATV systems. Bonding is the process of connecting metallic components together to create an electrically conductive path. The purpose of bonding is to minimize voltage differences between metallic components, which can reduce the risk of electrical shock. The NEC requires that all metallic components of CATV systems, including coaxial cable shields, equipment enclosures, and grounding electrodes, be bonded together. The bonding conductors must be sized in accordance with NEC Table 250.102. C1 based on the size of the service entrance conductors. The bonding conductors must be installed in a manner that minimizes impedance. This can be achieved by using short, direct bonding conductors and by avoiding sharp bends in the conductors. In addition to the general bonding requirements, the NEC also provides specific bonding requirements for CATV systems that are installed in or on buildings with multiple occupancies. In these cases, the CATV system must be bonded to the building's grounding electrode system at each point where the coaxial cable enters the building. This helps to ensure that the CATV system is effectively grounded, even if the building's grounding electrode system is not adequate. It is important to note that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to ensure that a CATV system is properly grounded and bonded. For example, in areas with high soil resistivity, it may be necessary to install additional grounding electrodes to achieve the required grounding resistance. Similarly, in buildings with sensitive electronic equipment, it may be necessary to install surge protective devices to protect the equipment from voltage surges. In summary, NEC Section 820.96 provides specific requirements for the grounding of CATV systems. These requirements are designed to ensure that CATV systems are properly grounded and bonded, which helps to protect equipment and personnel from electrical shock. When installing a CATV system, it is important to carefully review NEC Section 820.96 and to follow all of the applicable requirements. The grounding conductor must be as short as practicable, not exceeding 20 feet, and shorter than the grounding electrode length. Proper grounding and bonding are essential for the safe and reliable operation of CATV systems. Other relevant NEC sections that relate to grounding and bonding of CATV systems include Article 250, which covers grounding and bonding in general, and Article 800, which covers communications circuits. These articles provide additional information on the requirements for grounding and bonding electrical systems. It is important to understand the relationship between these different articles in order to ensure that a CATV system is properly grounded and bonded. The grounding electrode conductor connects the grounding electrode to the equipment grounding bus or the neutral bus at the service equipment. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. The equipment grounding conductor connects the non-current carrying metal parts of equipment to the grounding system. The size of the equipment grounding conductor is determined by NEC Table 250.122 based on the rating of the overcurrent protective device protecting the circuit. The purpose of the equipment grounding conductor is to provide a low impedance path for fault current to flow back to the source, which helps to ensure that overcurrent protective devices will operate quickly and effectively in the event of a fault. In addition to the requirements for grounding conductors, the NEC also provides requirements for the installation of ground clamps and connectors. Ground clamps and connectors must be listed for the purpose of grounding and bonding and must be installed in accordance with the manufacturer's instructions. Ground clamps and connectors must be made of materials that are compatible with the conductors they are connecting. For example, copper conductors should be connected using copper or copper alloy connectors. Aluminum conductors should be connected using aluminum or aluminum alloy connectors that are specifically listed for use with aluminum conductors. The use of dissimilar metals can lead to corrosion and can compromise the effectiveness of the grounding system. It is important to inspect grounding systems regularly to ensure that they are in good condition. Grounding conductors and connections should be checked for corrosion, damage, and looseness. Any damaged or corroded component should be replaced immediately. Loose connections should be tightened to ensure that they are making good electrical contact. Grounding systems should also be tested periodically to verify that they are providing adequate grounding protection. Ground resistance testing is a common method for evaluating the effectiveness of a grounding system. Ground resistance testing involves measuring the resistance between the grounding electrode and remote earth. The measured resistance should be below a certain value, typically 25 ohms or less, to ensure that the grounding system is providing adequate protection. In addition to ground resistance testing, other tests can be performed to evaluate the condition of a grounding system. These tests include continuity testing, which verifies that there is a continuous electrical path between all grounded components, and impedance testing, which measures the impedance of the grounding path. Proper grounding and bonding are essential for the safe and reliable operation of electrical systems. By following the requirements of the NEC and by performing regular inspections and tests, it is possible to ensure that grounding systems are providing adequate protection against electrical shock and equipment damage. In the context of CATV systems, the grounding requirements are particularly important because CATV systems are often exposed to voltage surges from lightning strikes and other sources. Proper grounding and bonding can help to protect CATV equipment from damage and to prevent electrical shock to people who may come into contact with the equipment. The NEC requirements for CATV grounding are based on established engineering principles and are designed to ensure that CATV systems are installed in a safe and reliable manner. By following these requirements, it is possible to minimize the risk of electrical hazards and to protect equipment from damage. The role of the authority having jurisdiction, (OJ), is to enforce the NEC requirements. The AHA is typically a local building inspector or electrical inspector who is responsible for ensuring that electrical installations comply with the applicable codes and standards. The AHA has the authority to approve or disapprove electrical installations and to require corrections to be made if the installations do not comply with the code. It is important to work with the AHA to ensure that a CATV system is properly grounded and bonded. The AHA can provide guidance on the applicable code requirements and can help to resolve any questions or concerns that may arise during the installation process. In addition to the NEC, there may be other applicable codes and standards that relate to the grounding and bonding of CATV systems. For example, some local jurisdictions may have their own electrical codes that are more stringent than the NEC. It is important to be aware of all of the applicable codes and standards and to ensure that a CATV system complies with all of the requirements. The proper installation and maintenance of CATV grounding systems requires a thorough understanding of the NEC requirements and a commitment to following best practices. By working with qualified electricians and by following all of the applicable codes and standards, it is possible to ensure that CATV systems are installed in a safe and reliable manner. Remember that safety is always the top priority when working with electrical systems. Always take the necessary precautions to protect yourself and others from electrical shock. If you are not qualified to work on electrical systems, always hire a licensed electrician to do the work. Grounding and bonding are critical aspects of electrical safety, and it is important to ensure that these systems are properly installed and maintained. For CATV systems, the NEC provides specific requirements for grounding and bonding that must be followed to ensure the safety of people and equipment.